Hello everyone, I'm Mamta Nikam and I'm here with a video on another topic of matrices, that is rank of a matrix. Let us see what is rank of a matrix. So a rank of a matrix is defined as, or you can say a matrix is said to be of rank R if it satisfies two conditions. What are those conditions? The first condition says there exists at least one minor of order R which is not equal to 0, and every minor of order R plus 1 is equal to 0. Then the rank of a matrix is the maximum order of its non-vanishing minor, whereas the rank is denoted as row of A equal to R. So suppose we consider a matrix, say it is 1, 2, 4, 2, 4, 6, 4, 6, 8. Okay, this is a matrix of order 3 cross 3. If you calculate the minors, what are minors? The determinants of its uh, smaller order. So you can, if you have to calculate the minor of order of the element, first element 1, how do we find? We eliminate or neglect the first corresponding row and column, and we define the determinant value of the remaining terms. That is a minor. So accordingly we can calculate the minors of all the terms elements present in this matrix. So minor, if you calculate the any of the minor of order 2 cross 2 more terms, what is we observe? If you calculate this minor, it is going to be 4 minus 4, it is going to be 0. Okay, if you calculate the another minor or next order, this is going to be 12 minus 16. So if you observe, it is minus 4, which is a non-zero term. Okay, so the first condition says at least one minor of order R is not equal to 0. So we observe that we find at least one minor of order 2 which is not equal to 0. And if you find a minor of order 3, that is the determinant, if we calculate, we observe it is equal to 0. That is the second condition, every minor of order R plus 1. So if you consider R is equal to 2, then the minor of order R plus 1, that is 3, turns out to be equal to 0. Means both the conditions for this matrix here are satisfied, and therefore the rank of this matrix, that is the maximum order of its non-vanishing minor. So non-vanishing minor is of order 2, and therefore the rank of the given matrix A is equal to 2. Okay, similarly we can calculate if for given a 4 cross 4 matrix, 5 cross 4 matrix. Okay, let us discuss a few important points. If you have a matrix which has non-zero minor of order R, then we observe then the rank of A might be greater than or equal to R. It might be equal to R, or it can be also greater than R, depending on the order of a matrix given. Second, if a matrix has all the minors of order R plus 1 as 0, then the rank of A is either equal to R or less than R. Suppose you have a matrix which is of order m cross n. Means if you don't have a square matrix, if you have a matrix say order 3 cross 4, or you can say 5 cross 4. If you observe such order matrices, then the rank of A give matrix is less than or equal to minimum of this m and n. Means minimum of, suppose you have a 3 cross 4 matrix, then rank of A will be less than or equal to minimum of 3 comma 4. Okay, next, suppose you take a transpose of a given matrix, then we observe the rank of our matrix, the transpose matrix, is same as that of the original matrix. Okay, next, suppose you have two matrices A and B, and if you take a product of these two matrices, say A into B, and if you find the rank of this matrix AB, newly formed product matrix AB, then we observe rank of AB is does not exceed the rank of either of the matrix A or matrix B. That is, rank of AB is less than or equal to rank of A, or it is also less than or equal to rank of B. Okay, now note the one thing, that elementary transformations do not alter the rank of a matrix. Also, it do not alter the order of the matrix. Performing elementary transformations and reducing the matrix to get a or to determine the rank of a matrix do not alter the rank of a matrix. And if suppose you perform some elementary transformation given a matrix A, and if you perform some elementary transformations and we obtain a new matrix say B, then we call A is equivalent to B, denoted as A equivalent to B. Okay, so these are the few important points we remember. So now rank of a matrix. Next, when we perform elementary transformation, in simple language, we define rank of a matrix as number of non-zero rows present in the matrix. On performing elementary transformation, the matrix given matrix A reduces to another matrix. That matrix, in the reduced matrix, we decide or we look for number of non-zero rows. The number of non-zero rows gives us the rank of a matrix. Now, performing elementary transformations, now there are two conditions or two methods to which we can reduce the matrix. Now, out of which the first is reducing the matrix to echelon form. Okay, and the other one is on reducing the matrix to normal form. Both methods can give us the rank of a matrix. So, reducing to echelon form. What is an echelon form of a matrix? So now, suppose A is a matrix given to us of order m cross n. Then row echelon form of a matrix is nothing but a matrix where we observe that one or more elements in each first row are non-zero and the elements in remaining rows are non-zero. Okay, and the second condition says if first are rows, the first non-zero element in each row appears to in a column to the right of the first non-zero element of the preceding row. Now what does this? Suppose we have a matrix as say okay, so if this is a matrix we are having, then the such form of a matrix is known as an echelon form of a matrix. That means if you observe, the first r rows here are non-zeros, whereas the remaining rows are zero rows. If it would have been, if you there would be a matrix of the form say such would be a matrix. Next, and if you observe the difference, there is an element, a non-zero element in the last row. If there exists at least one non-zero element in a row, that row is considered as a non-zero row. And if there are all zero terms or zero term elements in a row, such row is known as a zero row. Okay, so that definition says that if there exist one or more elements in each row which are non-zero, and if there are elements in the remaining rows are zero, then such form is known as echelon form. Echelon form is also known as, another term is also known as canonical form. Okay, and if you observe the r rows, the first non-zero element in each row appears to the right of the first non-zero element of the preceding row. Means if you observe the first row, the first element is here in the first corner. Then if you observe the second row non-zero element is to the right of the first column, first non-zero element. Then if you observe the third row, in the third row the non-zero element is present to the right. Okay, or you can also observe one more observation or one more trick you can remember, that if you there is a matrix, there is a there is a given a matrix and first element is non-zero, whereas all the elements below it are zero. Again in the second row, first element is non-zero and all the elements below it are non-zero. Similarly, if you observe the third row, first element is 0 and all the elements are non-zero. Such form of matrix is known as echelon form of a matrix. Or also you can remember it as the elements below the diagonals are 0. Now not necessary every time the diagonal element and might be present, it can also turn out to be 0. So number of non-zero rows, when you convert the given matrix into such form of a matrix, that is an echelon form of a matrix, then the number of non-zero rows here give us the rank of a matrix. Okay, so when a matrix is reduced to echelon form, the number of non-zero rows in a matrix is a rank of a matrix. I'll write down the example again, a matrix form again. फर्स्ट एलिमेंट, रिमेंबर फर्स्ट एलिमेंट, उसके नीचे के सारे एलिमेंट 0. अगेन इन द सेकेंड रो सेकेंड एलिमेंट, उसके नीचे के सारे एलिमेंट्स 0 करने हैं. देन थर्ड रो थर्ड एलिमेंट and then again 0 below it, and so on depending on the order of the matrix. Now since this is a 4 cross 4 matrix, accordingly we have to perform the transformations, reduce the given matrix to an echelon form, and then decide how many number of non-zero rows we obtain. Here we observe there are 3 number of non-zero rows, and therefore rank of this matrix is equal to 3. So let us discuss an example. Let us find the rank of the given matrix. Now we will be performing elementary transformation. We will perform row transformation and reduce the matrix to echelon form. One more thing you keep in mind, while reducing to row echelon form, make sure your first element is always unity, is equal to 1, is 1. That will make our simplification or reduction to echelon form more easier. Or the echelon, in the echelon form, the first element is always equal to 1. Okay, so now if you observe the given matrix here, the given matrix, the first element is equal to 2. So what we do, we interchange, and if you observe the third row and fourth row, it has first element as 1. What we do, we interchange the first and third row and bring this 1 to the first row so that it will make our further transformations easier. So first row transformation kya karoge? R1 interchanged with R3. So the matrix A now turns out to be 1 minus 1 0 3 4 2 0 6, then 1 minus 1 0 3, and the last row, I'm sorry, the third row here, it is going to be 2 minus 2 0 6, and the last row, that is 1 minus 2 1 2. Okay, now what we have to do, फर्स्ट एलिमेंट वैसे ही रखना है एंड उसके नीचे के सारे एलिमेंट्स को 0 करना है. ओके, मीन्स दिस 4 2 एंड माइनस 1 सॉरी प्लस 1, वी हैव टू कन्वर्ट इट टू 0. सो क्या ट्रांसफॉर्मेशंस करेंगे हम यहाँ पे? वी विल परफॉर्म टू फॉर did you make this 4 term 0, we can perform R2 minus 4R1. Similarly, to make this 2 element 2 term 0, we can perform R3 minus 2R1, and to make this 1 0, that is the last element, we can perform R4 minus R1. So on performing this transformation, the newly formed matrix will be, first row will remain as it is, 1 0 1 minus 1 0 3, then 4 minus 4 will be 0. Second row we will first calculate, then 2 minus of minus plus 4, that is 6, then 0 minus 0 will be 0, then 6 minus 12 will be minus 6. Now third row, 2 minus 2 0, then minus 2 and plus 2 again this will be 0, 0 minus 0 will be 0, 6 minus 6, this will be 0. Fourth row, 1 minus 1, 0, then minus 2, 2 minus minus plus 1, that is minus 1, then 1 minus 0, 1, and 2 minus 3, this will be minus 1. So if you observe now here, the third row totally turns out to be a 0 row. So what we do, we will bring this to the last. We will interchange the third and fourth row. So next transformation what we will perform, interchanging third and fourth row. So rank, this new form matrix will be now 1 minus 1 0 3 0 6 0 minus 6 0 0 0 0, sorry, third fourth row ऊपर जाएगा तो 0 minus 1 1 minus 1 and the last row will be 0 row. Now if you observe the second and third row again, here we have a minus 1 and here it is a bigger number. So smaller number we will shift to upper side. So we will perform another transformation, R2 interchange R3, so that नीचे के एलिमेंट 0 करने में आसानी हो जाएगी. So 1 minus 1 0 3 0 minus 1 1 minus 1 0 6 0 minus 6 0 0 0 0. Now we have to observe the second row and second element in it. सेकेंड रो सेकेंड एलिमेंट, उसके नीचे के सारे एलिमेंट्स को 0 करना है. एक तो ऑलरेडी 0 है, वी हैव टू कन्वर्ट द 6 टर्म टू 0. So what will be the transformation we can perform here? Or we can perform R3 plus 6 times R1, right? See, since here it is already a minus sign, we will perform R3 plus 6 R1. So क्या होगा ये matrix? This will be first row as it is 1 minus 1 0 3 0 minus 1 1 minus second row also as it is. We are performing on third row. So third row will now become 0, then 6 minus 6 0 0 plus 6, this will be 6, minus 6 and minus 6, this will be minus 12, and the last row, that is 0. Okay, so now if you observe the third row and third element, उसके नीचे ऑलरेडी हमें 0 मिल गया है. So there is no need to further perform that any transformation. If you want, you can reduce this third row so that it will be a lower term here. You can divide this third row by 6. So if you divide R3 by 6, the matrix will turn out to be 1 minus 1 0 3 0 minus 1 1 minus 1 0 0 1 minus 2 0 0 0 0. So now if you observe the newly formed matrix, we observe there are 3 non-zero rows, whereas 1 is a 0 row. So number of non-zero rows is nothing but the rank of a matrix. Therefore rank of A is nothing but number of non-zero rows. And how many number of non-zero rows we have? Number of non-zero rows are equal to 3, and therefore rank of A is equal to 3. Also you can write this as how many number of rows we rank as number of rows which are given in the matrix minus number of 0 rows we obtain. So number of rows total we have in the matrix, that is 4. Number of 0 row, this is a 0 row, last row, that is 1, and therefore rank of the given matrix is equal to 3. But simple will be keeping in mind that is one segment, number of non-zero rows, and here in this given matrix, number of non-zero rows we obtained as 3, and therefore rank is 3. Let us discuss one more example. given a matrix. Now again we observe what do we need. First element 1 to make our further transformations easier. So first element, it is already given 1 here for a in this given matrix, so no need to perform any interchanging transformation. Given matrix is 1 2 3 4 2 1 4 3 3 0 5 minus 10. Now next we have to perform transformations such that first element के नीचे सारे elements should be 0. So first transformation we can perform R2 minus 2R1 and R3 minus 3R1, and therefore the matrix turns out to be 1 2 3 4. Then second row, first row remains as it is. Performance transformation on second row, 2 minus 2 0, 1 minus 4 minus 3, 4 minus 6 minus 2, 3 minus 8 minus 5. Then on the third row, 3 minus 3 0, 0 minus 6 minus 6, 5 minus 9 minus 4 minus 10 minus 12 minus 22. Now this turns out to be 0, all the terms. Now we have to shift to second row, second element, second row का first नॉन जीरो एलिमेंट, एंड इसके नीचे के एलिमेंट को जीरो करना है, मतलब -6 को जीरो करना है. So what transformation we can perform? We can perform the transformation as R3 minus 2R2. So this matrix will turn out to be first row as it is, second row will remain as it is, and now third row, first element 0, minus 6 minus of minus plus 6, so this will 0, minus 4 plus 4 0, minus 22 plus 10, that is minus 12. So this minus 12 further we cannot reduce it to 0, so it will remain as it is. If you want, you can reduce it, you can divide the row by minus 12 and turn out to be 1. That is also considered. So again, if you observe, there are number of non-zero rows. The first row, the second row, as well as the third row is also non-zero row, because there exists at least one element which is non-zero. So all the three rows are non-zero. So number of non-zero rows we obtain here is equal to 3, and hence rank of matrix given matrix A is equal to 3. I hope this term or this method is clear to everyone. So now this was one form of one method to find a rank of matrix by reducing to echelon form. The another form or another method to find a rank of a matrix is by reducing the given matrix to normal form. So now what is a normal form? When we perform elementary transformations of on a given matrix and we reduce the matrix, and on reduction we obtain any one of these four forms, such matrix such form of matrix is known as a normal form of matrix. What is here I? I is nothing but an identity matrix, or you can call an or unit matrix of order R. Means अगर तुम्हें we perform transformation, suppose now we are given a 4 cross 4 matrix, and when we perform row transformations, once now here to convert a normal into normal form, we perform row as well as column transformation. We have to use both elementary row and column transformations, so it is converted to identity matrix. So on performing elementary transformations, that is row and column transformation, if this matrix turns out to be, if you observe an identity matrix like this, and the last two rows and the two columns turns out to be 0, that means क्या मिला है यहाँ पे, एक identity matrix मिला है which is of order 2, and whereas other elements are null elements or 0 elements. Hence then this matrix or the rank of this matrix turns out to be 2. If you would have observed यहाँ पे भी 1 आ जाता, that is this matrix is turned out to be an identity matrix of order 3, then rank would have been equal to 3. So what we have to do, we have to perform elementary row and column transformations and reduce such that we obtain an identity matrix. Now it can be only an identity matrix, or you can observe you get an identity matrix and one column that is 0. Okay, if then you can observe you form such a matrix where we obtain an identity matrix and one row is 0, or you can find matrix where you have you observe an identity matrix and one or more rows as well as columns are 0. Such forms, all such forms are known as normal forms, and reduction to the normal form gives us rank of a matrix. So the number R here represents the rank of A. What do we note? Note that we have to perform row as well as column transformations here. And also remember, elementary transformations do not alter the rank of a matrix. Means if you perform first row and then column, or first column and then row, or you can go simultaneously row and column, it is not going to affect on the rank. You will get what is the expected rank of a matrix. Fine. So let us see an example based on this. Have to reduce the given matrix to normal form and reciting the rank. So given a matrix A, now here we have to reduce this matrix to normal form. Normal form मतलब क्या करना है? Keep in mind, we have to bring an identity matrix here. We have to reduce such that we obtain an identity matrix. Again, now what we'll do, we will go simultaneously row and column, ऐसे दोनों use करके we will go, that will be easier. So first we will perform row transformations. So performing row transformation, given matrix A दिया गया है 1 2 1 0, then -2 4 3 0 1 0 2 -8. Okay, and अभी इसे reduce करना है हमें, such that it is a identity matrix. We obtain an identity matrix. So we perform a row transformation. That is, first element we will keep as it is, 1 है we will keep as it is. इसके नीचे के सारे elements को 0 करना है. So what do? We will perform row transformation as R2 plus 2R1 and R3 minus R1. Then A will be first row as it is, 1 2 1 0. Then -2 plus 2 0, 4 plus 4, this will be 8, then 3 plus 2, that is 5, and 0 plus 0 will be 0. Third row, 1 minus 1 0, 0 minus 2 minus 2, then 2 minus 1 1, and -8 minus 0 minus 8. So ये होगा row transformation. Now we will have to perform column transformation, क्योंकि identity करना है, मतलब 1 के नीचे भी 0 आना चाहिए और साइड में भी 0 आना चाहिए. तो 1 फर्स्ट एलिमेंट ऑलरेडी है, इसके नीचे 0 मिल गया, अभी इसके साइड के एलिमेंट्स को 0 करना है. सो साइड के एलिमेंट्स को 0 करना है, मतलब इस 2 और 1 column C3 and C4 we have to perform transformation. So what transformation we will perform? To make C3 we will perform C2 and C3. So C2 हो जाएगा C2 minus 2C1 and C3 minus C1. Performing this transformations, these elements will turn out to be 0. And since here it is 0, it will not affect on another terms, remaining terms in this matrix. So the matrix now is reduced to 1 first column as it is, 2 minus 2 0, 8 minus 0 8, minus 2 minus 0 minus 2, then 1 minus 1 0, this will be 5 1 0 0 minus 8 as it is. Now first row का first column हो गया. Now come to the second row. Second row we had need here 1, but this is a bigger number, and we have minus 2 here. So what we'll do, time being, we'll keep this term as it is, and we'll reduce, or we'll uh, reduce this or to minus 2 to 0. We'll convert this, perform such transformation that it will be minus 2 will turn out to be 0. Or what you can do, you can first interchange both these rows and then perform transformation. That will also give you the answer. So if you perform this rows R2 interchange with R3, we will get a matrix as 1 0 0 0 0 minus 2 1 minus 8 0 8 5 0. And now if you have to turn out this, convert this element to 0, what transformation will perform? We can perform R3 plus 4 R2, because this is 8 minus 8 will give us 0. So A matrix हो जाएगा 1 0 0 0 0 minus 2 1 minus 8. Now third row 0 8 minus 8 0 5 plus 4 9 0 minus 8 into 4, so this is going to be minus 32. Okay, now next, what do we want? We want column transformations. Now if you observe the column, second column and third column, here we have 1 and here it is minus 2. Better we will interchange for C2 and C3 and then perform column transformation. So we can perform interchange C2 and C3. That will make our transformations easier, just a bit easier. You can also keep it in their places and perform transformations. That will also do. So this will be 1 0 0 0 1 9 0 minus 2 0 0 minus 8 minus 32. But now if you observe, when we perform C2 interchange C3, क्या हो रहा है, ये फिर से 0 हो रहा है, यहाँ पे फिर से नॉन जीरो एलिमेंट मिल रहा है, मीन्स जो हमें नॉन जीरो नहीं चाहिए था वो मिल रहा है. सो अगेन यहाँ पे हमें कुछ रो ट्रांसफॉर्मेशन करना पड़ेगा सो दैट फिर से ये 0 हो जाए. So either you perform again row transformation or avoid going for column interchange and perform where it is as it is. So column transformation अगर करना है तो क्या करोगे? We can perform 2c3 plus c2 here. So 2 times 2 minus 2 will give us 0, and this is minus 8 को 0 करना है. So we can perform c4 minus 4 c2, that is minus 8 plus 8 will give us 0. So the matrix will be 1 0 0 0 minus 2 0. I keep it as it is. Then 0 minus plus 2 minus 2 will be 0. 9 2s are 18 plus 0 will be 18. Then fourth column क्या हो जाएगा? 0 minus 8 plus 8 0 minus 32 and 0, so this will be minus 32 as it is. So now if you observe the columns, if I divide each column, there is only one element in each column, other are all 0 elements. So I can perform C2 divided by minus 2, I can perform C3 divided by 18 and C4 divided by minus 32. So this matrix turns out to be 1 0 0 0 1 0 0 0 1 0 0 1. And if you now again if you observe the last row here and last and the second last column C3 and C4, it has same element in last row, we can perform C4 minus C3, so that this turns out to be 0. Column transformation क्योंकि 1 के साइड में 0 हो रहा है, so this turns out to be A 1 0 0 0 1 0 0 0 1 0 0 0. So if you observe here, we obtain an identity matrix here of order 3 cross 3 and one column that is a 0 column, right? So this is nothing but an I3 0 form. this is another one of the normal forms, and therefore what is I3? This 3 is nothing but a order of the identity matrix and ultimately the rank of a matrix, and therefore rank of a matrix here is equal to 3. And such manner we obtain reduce the given matrix to normal form and obtain the rank of a matrix. Similarly, given any form of a matrix, you can perform row and column transformations, reduce the matrix to any of the normal form which we have seen, and that will give us the rank. I hope this topic, rank of a matrix, is clear to everyone. Thank you.